Okay, so the last couple of lessons what we looked at was the arithmetic sequences and how you can work out the value of a term in an arithmetic sequence. And we looked at geometric sequences and how you can work out the value of a term in a geometric sequence. And today we're going to look at the sums in arithmetic sequences. So we've looked at this before, we're just going to go back and recap it before we do the sum of geometric sequences next lesson. So the sum of arithmetic sequences, what we mean here is if I gave you a sequence, say 1, 2, 3, 4, 5, and then I said, okay, what is the sum of all of the terms up until the 10th term? So you'd be adding together 1 plus 2 plus 3 plus 4 and so on until you get to the 10th term. Now there's two ways that we can work this out, because obviously if you have a simple sequence like that, it wouldn't take too long to add together the first 10 terms. But you don't want to do that with a more complicated sequence. So we've got these two equations here to let us work out the sum of an arithmetic sequence. And there's a reason that there are two of them, because there's a slight difference between them. So I just want you to pause the video here, and I want you to make one list of similarities. All the things that are similar between the first and the second equation, and then one list of differences. So things that the first equation requires that the second one doesn't need, and things that the second equation requires that the first one doesn't need. So pause the video here and make your two lists, one of similarities and one of differences. Okay, so this is quite important really, because this is what you'll use to work out which equation you're going to use. And don't forget, these equations are in your formula booklet, so they're always there available to you. You don't need to memorise them, but you do need to know how and when you're going to use them. So the similarities, both of them, we need to know the term number. This is because it's no use me saying to you, I have a sequence 1, 2, 3, 4, 5. What is the sum of the first n terms? Well, that doesn't make any sense. There's no way that you can work out the sum of the first n terms. You need to know how many terms you're adding together. So you have to know n to use these equations. The second is that they both need the first term. So you can see here, here's where n is used, and here is where n is used in the first one as well. Here is where the first term is used, u1. So you have to know what the first term in your sequence is. And they both multiply by half of the term number at the beginning. So that's a similarity. You're going to half the term number and then multiply the rest of your equation by it. So what are the differences then? When would I choose to use the first one and when would I choose to use the second one? Well, equation 1 asks you to know what the common difference is. So you need to know the difference between each of the values in your sequence. Now, in most cases you'll know that. Either the question will give it to you, it will say that the common difference is such and such, or you'll be able to work it out from what you're given, but not always. In some situations you might be given the first term and you might be given the last term, and you've got to work out the sum of sequences, the sum of the sequence. In that case, you'd want to use this second one, because here we use the first term and we use the last term. un means the term, the value of the term for the last number that we're interested in. So if you know the difference, you can use the first one. If you know the last number in your sequence, you can use the second one. In some cases you might be able to use both, and that's absolutely fine. You then pick the one you prefer working with. So let's have a look at some of these in action, and then I'll give you a go. So we use S of n, the sum of arithmetic terms, when a question asks you for the value of a certain number of terms added together. So, for example, a sequence has the first 5 terms 2, 4, 6, 8, 10. What is the sum of the first 10 terms? Now in this case, I'd start to write down what I already know. What things do I know here? Well, first things first, I know what n is, and that's very important because I know both of these equations require me to know what n is. N, in this case, is going to be 10. That's the term number that I'm interested in. I know u1, and both of these equations use u1, so that's also very important. u1, the first term, is 2. I also know what the common difference is, because I can tell that between 2 and 4, and between 4 and 6, and 6 and 8, the difference is 2. What I don't know is my last term. I don't know what u10 is. So I actually can't use this equation. This equation is useless to me. So I know I'm going to use this one. The first thing I do is write it out. Even though it's in the formula booklet, I would write it out to show that I know which equation I'm using. The next thing I do is then substitute in very, very clearly, showing which numbers I'm using for each section. So I've got S of n, the sum of n terms, in this case it would be S of 10, equals 10 divided by 2, because n is 10, 10 divided by 2, all multiplied by 2 times the first term, which is 2, plus n minus 1, 10 minus 1, multiplied by the common difference, also 2. And then I'd carry out my calculations until I got to the value 110. So I'd write down what I have first of all, so that I can work out which equation I'm going to use. Then I'd write out the equation, write out the substitution to show the examiner that I know exactly what I'm doing, and then I'd do the calculation. Let's have a look at another example then. So, a sequence has the first 4 terms -3, 1, 5, 9. And the final term is 81. What is the sum of these terms? Now the issue here, let's look at what I do know. I do know u1, the first term. So that's fine. Both of these use u1. And I have that. That's not a problem. I know what d is, because it's the common difference, which is 4. I know what un is in this case. The last term is 81. So I could use this equation here. The only problem is I don't know what n is. I don't know how many terms are in my sequence. I don't know how many terms it's taken me to get from -3, the first term, to 81, the last one. So I actually can't at the moment use either of these equations because I don't know what n is. So the first thing I need to do here is go back to my equation from last lesson on arithmetic sequences. And I need to substitute my values in here to find out what n is. So let's have a look at how we're going to do that. So the first thing is I'm going to write out this equation. And this was the equation for finding any term number given this information here. So I've got un, the final term. In this case is 81, because the question tells me so. And it's equal to the first term, -3, plus n minus 1 times d. Now I don't know what n is at the moment, so I'm leaving that there. n minus 1 multiplied by d, which I've worked out is 4. So I'm putting 4 in here. And I'm just going to rearrange my equation. So I can move this -3 to the other side by adding 3 to both sides. That gets rid of this -3. So I'm going to add 3, and I get 84 on this side equals 4 times n minus 1. Now at the moment there's not much I can do with this n minus 1 because I don't know what it is. But I'm multiplying the whole thing by 4. So to get rid of that I can divide both sides by 4. 84 divided by 4 is 21. So 21 equals n minus 1. Now all I need to do is get rid of that 1 to find out what n is. Or get rid of that minus 1. So I'm going to add 1 to both sides to get rid of the minus 1. And I end up with 22 equals n. So that means to get to 81 I must have had 22 terms in total. So now I know what n is, it's 22. And I'm going to substitute that in to one of my equations. Now in this case I can actually use either of them because I know what d is and I know what un is. So here I've written out the equations and I've substituted that information in and I've come out with 858 using both equations. That's just a really nice way of being able to check that you've got the answer correct, is if both equations come out with the same value. Okay, so here's some steps for you to take to make sure that when you come across these questions, you know how to answer them. The first thing is to write down the formulae that you know. You'll have them in your data booklet, but I would write them down on the paper as well, if you've got space. Write down the symbols and the values for everything that you can. So here's an example. A sequence has the first 4 terms, well this is the one that we just used. In this case I would write u1 equals minus 3, the first term is minus 3. d equals 4, the common difference is 4. un, the last term that I'm interested in, is 81. n, I don't know. So I know that I'm going to have to find out what n is. And I'd use my first equation to work it out. I would look at my equations and I'd think, right, which ones can I almost completely fill in apart from one missing value? And then I'd use that equation to find my one missing value by rearranging. Then I can substitute the information that I have into the next equation if I need to, just like we did in the last question. So I found out what n was and then I went to my next equation and substituted in. Do not forget to use the data booklet for sequences. It really is very, very useful and it means you don't have to memorise all of these terms. Okay, so could you carry out please exercise 7b, pages 301 to 302, all of the questions. Here are the answers, but I'd like you to cover up this screen now, get on with the questions and then come back and check your answers as you go.